The mysterious world of K2-18b. Are we closer to finding alien life? As you gaze into the vastness of space, witnessing the endless twinkling dance of billions of stars, each one seems to whisper a timeless question: are we truly alone in the universe? For centuries, humanity has looked up and wondered if there could be life beyond our tiny blue planet. Now, in the 21st century, we are finally beginning to peel back the curtain. Thanks to one of the most powerful telescopes ever created, the James Webb Space Telescope, we are entering a new era of space exploration, one that may bring us closer to answering that age-old question. The James Webb Space Telescope, often abbreviated as JWST, is not just another eye in the sky. It's a revolutionary piece of engineering that acts like a magnifying lens for the cosmos, allowing scientists to observe galaxies, stars, and planets in stunning detail. And recently, JWST turned its attention to an especially intriguing subject: K2-18b, a distant exoplanet located about 120 light-years away in the constellation Leo. This mysterious world has captivated scientists since its discovery, but recent observations by JWST have added an entirely new layer of fascination. K2-18b is what astronomers call a sub-Neptune. That means it's larger than Earth, but smaller than Neptune, a class of planets we don't actually have in our own solar system. These in-between planets are mysterious, unfamiliar, and difficult to categorize. But what truly sets K2-18b apart isn't just its size, it's what's in its atmosphere. The James Webb Telescope detected water vapor, a substance so closely tied to life as we know it that its presence on another planet immediately ignites the imagination. Even more intriguing, scientists identified methane, CH, and carbon dioxide, CO. Both are significant, as they can be produced by geological processes, but also by living organisms. But the real game changer? A potential detection of dimethyl sulfide, DMS. This compound is only known on Earth to be produced by living organisms, mainly by marine microorganisms in our oceans. To be clear, this does not confirm alien life. But if confirmed, DMS would be one of the strongest biosignatures we have ever found beyond Earth. This discovery raises more questions than answers, and it demands deeper investigation. K2-18b orbits its parent star, K2-18, a cool red dwarf, then what is known as the habitable zone. This is the range of distance where conditions might allow for liquid water to exist, an essential ingredient for life. Interestingly, K2-18b orbits much closer to its star than Earth does to the Sun, just 0.18 astronomical units. O stands for astronomical unit, which is the average distance between Earth and the Sun. Despite this closeness, the planet isn't a scorched wasteland. Red dwarf stars emit far less heat than our Sun, which means K2-18b might maintain temperatures suitable for liquid water, especially if it has a protective, hydrogen-rich atmosphere. That's why scientists are so excited. This distant world may not only support water in vapor form, but could potentially have entire oceans beneath its atmosphere. It's a tantalizing thought: a hidden ocean on a distant world, possibly teeming with life forms we've never imagined. So far, we've only just begun to scratch the surface. But the data from JWST hints at something extraordinary, something that demands a deeper dive. Hycean worlds and the hunt for life. The case of K2-18b, an exoplanet that has quickly risen to the forefront of astronomical interest thanks to recent observations from the James Webb Space Telescope. With potential signs of water vapor, methane, carbon dioxide, and possibly even dimethyl sulfide in its atmosphere, K2-18b is now considered one of the most promising candidates in the ongoing search for extraterrestrial life. But to understand what makes K2-18b so remarkable, we need to explore an exciting new concept in planetary science: the idea of Hycean worlds. In 2021, Professor Nikku Madhusudan and his team at the University of Cambridge proposed a new category of exoplanets that may radically alter where we look for life. They called them Hycean planets, a blend of the words hydrogen and ocean. These planets are thought to have massive oceans hidden beneath hydrogen-rich atmospheres. They are typically larger than Earth, some up to 10 Earth masses, and covered in a thick, insulating atmosphere that traps heat efficiently. This means liquid water could exist over a wider range of distances from their host stars, making habitable conditions more common than previously believed. Even though surface temperatures on these worlds could be extremely high, up to 200 degrees Celsius, 392 degrees Fahrenheit, life could still survive in stable subsurface oceans, protected from the harsh radiation and temperature fluctuations of the upper atmosphere. That's what makes K2-18b such a compelling case. It's roughly 2.6 times the radius of Earth and about 8.6 times more massive. It orbits its parent star, K2-18, a red dwarf, in the star's habitable zone, the region where liquid water could potentially exist. This red dwarf is cooler and dimmer than our Sun, so although K2-18b orbits much closer to it, just 0.18 astronomical units, the conditions may still allow for moderate, Earth-like temperatures. It's a delicate balance, and the planet's thick hydrogen atmosphere might help keep it just right. Now here's where it gets truly fascinating. Using transit spectroscopy, the James Webb Space Telescope observed the light from the star as it passed through K2-18b's atmosphere during the transit event. By breaking that light into a spectrum like a rainbow of invisible fingerprints, scientists could detect the unique signatures of molecules present. They found methane, carbon dioxide, and tantalizing signs of dimethyl sulfide, DMS. On Earth, DMS is produced almost exclusively by life, especially by microorganisms in our oceans such as plankton. While this is not proof of alien life, it's a powerful clue. If confirmed, DMS could represent the first real biological signature detected on a planet beyond Earth. It's important to stay cautious, though. The signal is weak, and more observations are needed to confirm it. Still, the combination of water vapor and carbon-based molecules makes K2-18b one of the most exciting exoplanets we've ever discovered. But the implications go far beyond this single planet. Hycean worlds like K2-18b may be far more common than rocky Earth-like planets. Because they're larger, they're easier to detect with current technology, meaning we may find dozens, even hundreds more in the coming years. These planets may host life in unexpected forms, thriving beneath dense atmospheres and vast, pressurized oceans. They remind us that life may not be limited to environments like Earth, it might be far more adaptable than we ever imagined. We're standing at the edge of a new frontier. Thanks to the James Webb Space Telescope and the growing field of exoplanetary science, we are closer than ever to answering one of humanity's oldest questions. Are we alone? K2-18b may not give us a final answer today, but it's opened a door, and what lies beyond could redefine everything we know. Milky Way, so, what do you think? Could life really exist on a Hycean world? Could K2-18b be the first place we discover signs of alien biology? Let us know your thoughts in the comments below. If you're enjoying this exploration of the cosmos, don't forget to like, subscribe, and share. Thanks for watching, and join us next time as we continue to uncover the secrets of the universe, one world at a time.